Here we have a logistics differential equation. We can solve this by separating variables. We don't see t listed here. We can get the p's on this side, and actually we are going to leave this here because we want to keep the left-hand side as simple as we can get it. So we have dp over p times 1 minus p over 300 equals 0.1 dt. Now let's try and simplify this left-hand side just a little. We'll multiply top and bottom by 300, and I'm going to distribute the 300 through, so it'll go here and cancel here. Then I'm going to integrate both sides, and this is going to involve partial fractions. I'm going to go down here at the bottom to do that. Then it looks like we have 300 over p times 300 minus p, so that would equal a over p plus b over 300 minus p. Now if we clear that of fractions, we would have 300 equal a times 300 minus p plus bp. So first of all, we could let p be 0, and that would leave us 300 equal 300a, so a would be 1, and then we could let p be 300, and that would give us 300 equal 300b, so b is also 1. So this can be expressed as the integral of 1 over p plus 1 over 300 minus p dp equals integral 0.1 dt. Now we can go ahead and do the integration. We've got the natural log of the absolute value of p plus, nope, that's not going to be a plus, and we've got to watch out for that because the derivative of this is a negative one, so we need the reciprocal of that out in front. So we need a negative natural log of 300 minus p equals 0.1 t plus a constant. Now we can combine these under one log, so that's the natural log of p over 300 minus p equals 0.1 t plus a constant. We're trying to solve this for p, so we're going to exponentiate both sides. We won't need the absolute values because exponentials are going to be positive here. So this is going to be p over 300 minus p equals e to the 0.1 t, and we're going to go ahead and call this c1 and then put this c out in front. We showed you that was because this is equivalent to e to the 0.1 t times e to the c1. E to the c1 is just a constant. Now this is actually a good place to find the c, because once we go to do the algebra to solve, it's going to end up in more than one place. So let's go ahead and do that now. We know that at 0 it is 50. So we can use this initial value to find the c. So we need to put in 50 for the p, so this would be 250, and then equals c, e to the 0 of course is 1. So it looks like our c is going to be 1/5. So let's go ahead and we can take this 1/5 and we can put it right here, but let's also multiply both sides by this to clear this a fraction. So we have p equal, and we'll go ahead and distribute this through. So 1/5 e to the 0.1 t times 300, that will be 60 e to the 0.1 t, and then minus 1/5 e to the 0.1 t p. Now what our goal was here was to solve this for p, so we're going to get both terms with p on the same side, so we'll move this term over, and we're going to go ahead and factor the p out in front as well. So that'd leave 1 plus 1/5 e to the 0.1 t on this side, and that equals 60 e to the 0.1 t. We're trying to solve this for p, so we can now divide by this, and we will have p equal 60 e to the 0.1 t over 1 plus 1/5 e to the 0.1 t. Now we're going to do one more algebraic trick to get this in a little bit simpler form. We're going to multiply numerator and denominator by 5e to the negative 0.1t. So 5e to the negative 0.1t. Now what that does for us is it gets this in a simpler form, because if we do that here, this will become e to the 0, which is 1. So this is going to leave us 300 over 5e to the negative 0.1t plus, and this is just going to become a 1 right here. So this is the solution to our logistics differential equation, and it lets us see what's going on with this fruit fly population at time t. And we can see the carrying capacity or limiting factor here, because if we let t approach infinity, so we're letting time go larger and larger, we know that as t gets large, this goes to 0, and we would have 300 over 1. So our carrying capacity is 300. We can see that in this solution. Here is a graph. We can see we started at 50, and we're going to climb with this thing, and we are going to approach that carrying capacity of 300.